Okay. So next, next what we have to deal with is another example of counting even numbers. So we just need to make the program read 3 inputs and calculate the number of even numbers among them. All right, so let's do that. So let's read 3 numbers, and 1 and 2 and 3. Then we have to store some value that represents how many even numbers we have. So let's say even numbers. Initially it has the value of 0. Then we have to check each number for evenness and update the counter. This variable is called the counter. It will count the number of even numbers. So how to check whether the number is even or not even? There is the remainder after division, and if we divide something by 2 without any remainder, that means the number is even. So for example, 100 divided by 2, the remainder after division is 0. Alright? 101 divided by 2, the remainder, 101, the remainder is 1. Alright, so this is not an even number. To check for evenness, it's enough for us just to use this percentage sign and check whether the result is 0 or not 0. So we have checked all 3 numbers over here and print the result. Yeah. I'm just copying the code. So your whole idea is to check, to type those. If n1 remainder of the division by 2 equals 0, then you increase the value plus equal to. Plus equal to, that means the same operation as even nums equal to even nums plus 1. It is the same. You don't need to type anything besides hashtag. This is just a commentary for you. So if we inputted anything which are not even, there are 0 even numbers, here's the output. Any questions here? All right, example 4. Sometimes you might, this example 4 actually corresponds to the input majorly. Sometimes you can see that the two different integers entered by the user in a single line. So, single line is the key here. That means we have to separate those integers somehow. Here they are separated by a space. So it should read a couple of integers separated by a space. How to do that? There is a special map operator. And for example, number 1 and number 2, they will be mapped integer values input just like that, and just let's print those two values. So you can see when we entered 1 and 2, those values are read as 1 and 2. Special map operator, it maps integer of load to this input. Here we can specify the input and how can we split. If we split just with simple brackets, it will be considered as space. We might separate them, split with commas, for example, just like that, or split with tabulation sign. We just place the /t. But anyway, we will see the majority of our task. You should see the splitting or separating with a space. So this is just the basics of how you read those numbers. Then we check whether those numbers are equal or not equal. If number 1 not equal to number 2, then we just print the minimum number 1 and number 2. Another case, print equal. Alright, so we placed, for example, some number like that and some number like that, and it doesn't matter what you print, it should work. If you placed -1 and 1, it will tell the smallest is -1. If you place 1 and -1 separated with the space, again the smallest one is -1. Place both zeros, numbers are equal. So always try to find the cases where your program might not work correctly. Here in those easy examples, it's obvious, but you might encounter the tasks where you have several conditions, several chain conditions, and you have to check border constraints there. All right, let's have a break. Stop the recording. All right, let's continue. So later on you'll do tasks 1 and tasks 3. Then let's talk about the logical operators. They often go alongside with comparison operators. These are and, or not. And these are the keywords and, or not. So for example, let's consider a program for ground sexes from 12 years old and who are 7th grade or higher, so access should be restricted for those who don't meet both criteria. So we have to check whether both criteria are met. And let's do that. We either create those two variables, we map integer to the input, and then check if both conditions are met. If age more than or equal to 12 and grade less than or more or equal to 7, then now sprint access denied. So basically let's enter our age and grade and check whether both conditions met or not met. 15 and 7, access granted. 20 and 2, 20 and 3, the access is denied. So both conditions should be true. The keyword and just makes sure that left hand side and right hand side around and both true. They should be true. If we need to place any other condition, we can modify the code. Create any arbitrary number of conditions. So for example, let's also check that the city is Kaohsiung. Those two variables are mapped with int. The third variable should be placed in the second line of code, and it should be string in order to check the city name. Enter city. So if age and grade and city only in this when all three conditions are met, only in this particular case the access will be granted. So the first line requires you to enter age and grade. Obviously, they are both. And if we enter caution here, then we should get the access granted. If any of those conditions are not met, then the AND fails to satisfy, and we just move on to the false state of else. We cannot place city here because city requires us to input text. But this text cannot be converted to integer. That's why we cannot place it. But if we have any other variable that might be integer, then just place grade, comma, something else, and 3 variables or 4 variables or 5 variables can be inputted in the single line separated with spaces. Alright, so here was the AND operator. We just make sure that all of those are true. OR operator, another operator which is satisfied if any of those conditions are true. So at least one condition should be true. Any of those conditions should be true. So let's check, for example, city. If city is Taipei, or city equals to Kaohsiung, or Tainan, for example. In those cases, Tainan is too long to enter in the single line. So in this case, we print access denied or print access granted. So just copy those lines. So always maintain the comparison. So city equal to Taipei or city equal to Kaohsiung. Comparison operator should satisfy. So, for example, we unintentionally place something wrong. Tainan, access denied. Place LA, access denied. Replace correctly LA, access granted. So no matter what city we enter which satisfies the condition, then it should be granted. The whole idea is situated over here. So X and I is true only both of them are true. X or I is true if at least some of them is true. Of course, we can combine those operators at the same time. No problem with that. No problem with that. Let's copy the previous code. Let's copy the previous code over here. And let's check whether the city type A or caution. And check whether the city is type A or caution. So city equals to or city. We can combine those operators. Moreover, I suggest that we place those values in brackets and maintain a single line of code, of course. Just like that. Let me help you with AG. C or C. Okay, now we can see that all those variables are here. All right. So we have entered 28 and type A, access granted. Some other city access denied. Of course, access will be denied if we enter like 10, 8 and type A, for example. Because the first condition is not met. Brackets just help you to modify the order of operation. So we just have to make sure that we check that A more or equal to 12, G more or equal to 7, and check this condition inside the brackets at the same time. Final keyword for today, not operator. So just the inverse of a logical expression. And we have to provide two code blocks. The first one, we check the age. We check the age. If not, and for example, age less 12, it is the same, completely equivalent if we place, instead of not age less than 12, the single change more equal to. Instead of not, we place more equal to. So these two code blocks are the same. If not age less than 12, well, that means it is more equal to 12. The most commonly used combination of keys is Ctrl-C, Ctrl-V here. Don't retype everything, just copy. Okay, so logical precedence. Logical precedence. So first of all, we check not operator. The second one is and the last one is or. And there are quite a few examples where you can actually mess up. So what I suggest, just make brackets. For example, if you need to check something, place the brackets. It's completely normal, just prevent you from any mistakes. Brackets just modify the order of execution. If you need to check whether both cities Gaussian or Taipei, place the brackets around. You'll be fine with that, and you make sure that those conditions will be checked instantly. So parentheses can be used to explicitly indicate the order of which conditions are evaluated. What else? Let me show you several errors that you might encounter. First of all, it's common when you check, when you are confusing with logical operators and or operator or. For example, these two conditions, if x more than 1 and x less than 100, something like that. What's the difference with this operator, if x more than 1 and x less than 100, and this operator? If x more than 1 or x than 100. What is the difference here? So the first condition actually checks whether the x belongs to the range from 1 to 100. The second condition checks that the number x is either greater than 1 or less than 100. What does it check? Any number satisfies this condition, because any number either more than 1 or less than 100. So here is any number satisfies. Just before using the operator, think what range you are expecting to have. Sometimes you can miss it. Second note, another frequent mistake is improperly framing the condition. Improper framing the condition. For example, if h more or equal to 7 and less than or equal to 9. So this is, here is a mistake. You shouldn't do like that. This is wrong. This is wrong. The correct way is to specify the variable and h less than or equal to. This is correct. And notice that Python tries to warn you by underlining less than or equal to sign. So it expects something. Expected expression. If I place the mouse on top, it shows view the problem. Expected expression. Something is wrong here. So always place, always explicitly write these conditions. Sometimes, instead of that, you can place, which is more preferable actually. We have already talked about chain conditions. This one is preferable. Correct and preferable. Both operators and or, they both use short circuit evaluation. That means if the left hand side condition is false, the right hand side condition will not be checked for AND because the outcome is already false. So for example, here in this particular case, if A we enter 10, the program immediately stops and goes to the else. So it checks on the left-hand side condition. Same kind of thing with OR. If the left-hand side condition is true, the right-hand side condition is not checked. What does it mean? Sometimes you might need to check some simple thing to the left, place this check to the left-hand side. And the right-hand side might execute another function or program which might last for hours. So it's the proper way of things, place easiest condition, which is not hard to calculate to the left-hand side, and then more harder, and then more harder. So the hardest one should be the last one. So this is a good way of doing this. Okay, so let me place those hashtags. Task 5, task 6, nested conditions. Nested conditions is another way to structure your code, actually. So there might be several conditions. If something is okay, else, and then in the other, if the first condition is not satisfied, then we go to the second condition. If it is not satisfied, then we go to the third condition, and so on. So we have so-called ladder of conditions or nested conditions. This type of example is already programmed, and we can see how we can determine the quarter of the point. So we just drop the point somewhere, x and y axis might be positive or negative, and we check the first condition, whether the x is positive and y is positive. So the point is somewhere here. We return 1. Why we return 1? Because all those conditions are placed inside the function. We can see the definition. The function is called determine quarter. It gathers input of x and y. X and y are inputted somewhere here in this line. They are floating point numbers, so we might enter actually, let's say 1.2 and minus 1.3, for example, and it shows that the quarter is 4. Why the quarter is 4? 1.2 is over here, minus 1.3 is over here, so the quarter is 4. How can we get here? 1.2 gets here, minus 1.3 gets here. It checks the first condition. 1.2 more than 0, and this one is not true. Then we go to the else. Then we check if x less than 0, no, because we have the positive number, we go here. Again, x less than 0, no, go here. X more than 0, okay, and y less than 0, both conditions are satisfied, and we return 4. Return ends the program to execute. That means all other lines which go after return, they are not executed. We're not checking them. Once we meet condition to execute return, we go out of the function. And the function just brings this output with it, only 4. For example, if we enter some 0, we can go further, so 0 and 0. And it returns origin. Why? Because it always checks those conditions, the first, the second, the third, the fourth, and so on, until it reaches the final condition. And the final condition is here. X not equal to 0 and y equals to 0. Return x-axis, no, it's not true. Else, all conditions are finished. It returns origin. Origin is this particular point 0, 0. So this is how we can place nested conditions. And you can see it's quite hard to look at them in the single screen. It's not the perfect way of things. And we can make this program to be more appealing and easier to understand, To make that, we can use so-called cascading condition. Okay, so nesting, that means we have a ladder. Cascading, we have the rectangular form of conditions. Let's create another function. Don't forget, when we enter the function, we must place the column operator in order to get inside the function. And then we provide those checks. And notice, once we enter determined quarter, we can see that there's an underlining, because the Python already knows that there is determined quarter function there. So let's create determined quarter new. Here we check both conditions and return 1. In order to make the program go as a cascade, we have to use else if operator. It is called like that, elif. Then we check another condition, x less than 0 and y more than 0. It will be second. Copy this code, Ctrl+C, Ctrl+V. Go over here. If x more than 0, y less than 0, third. Both of them, x more than 0, more than x less than 0, y less than 0, this is third, more than 0, this is fourth. Alright, so here we checked whether the code the point belongs to any of those 4 quarters. What else we have to check? What else we have to check? We have to check whether x is 0, y non-zero. In this particular case, we place y-axis. Here we place not equal to, y equal to. Finally, when we end all those conditions, we can place else and return origin. So here's our function. In order to enter, we gather a couple of points, we map floating point numbers to our input, just like that, and print name of the function with x and y input. So check how it works like that. I'll return a little bit 1 and 0, 0, 1, y-axis, 1 and 2 first, minus 1 and 2 second, minus 1, minus 1, third, and minus 1 and minus 2, 4. Okay, so it works fine, and this thing is much easier to understand than the program placed in nested conditions. All right, let's provide another example. Those conditions you can just copy out of here. You can see what is expected to return. Just copy those conditions and you'll get the same. All right. Convert a 100 point grid to a 5-point grid. I believe this is quite easy. Again, just to make sure that you understand what you will be required to do during small exam, you'll need to create the functions. So let's create those functions. Name this function somehow. Let's say convert grid. Make sure that you need to input something. If you may leave like that and provide the return. So here's the empty function. It just receives nothing and returns, for example, 1. To get something inside, we need to read again. So now the variable grade 100 will have some number, some floating point number, for example, 90.3 or 90.5 or 0. Another variable will be printed. So grade 5 will be convert grade, name of the function, with the input. So if you place grade 100 over here, this grade 100 will be considered as some variable inside the function. So some variable inside the function, it might be any number that any variable name that we have selected. So for example, n. So any number which goes to grade 100 goes over here it is considered as n internally inside the function. And then we provide conditions. More equal to 90, we place return 5. More equal to 80, 4. More equal to 70 and to 60. So here we covered all possible range, and we start from the highest grade. If this condition is not satisfied, we go to the second condition again up until we reach some return. So for example 75, it should return 1. So now grade 5, which holds the result of the function convert grade. Now it contains the value 3, as you can see. Grade 5 is 3. So if we need to print this, it will be printed as 3. Alright, enter 75. Enter 75 and got the result of 5-point grade is 3. Alright. So any variable that you print inside the formatted printing, F stands for formatted printing, then after F create the quotation marks, place some text, all the variables are placed inside curly brackets. Alright, final example for today, example 7, where we have to create the task using 3 approaches. Sometimes you may actually solve the tasks with different style of programming, different approaches. Anyway, each of those tasks will require us to enter 3 variables. So let me enter those 3 variables with the mapping, and then we will create the solution for 3 approaches. So we just initially enter 3 numbers ABC. They all have 3 possible choices. 3 if all the same, 2 if 2 the same, and 0 if all different. Alright. For the nested conditional statement, we will have to create several ifs and a couple of elses. So here's the solution using nested conditions. Initially we check first the numbers, are they the same or not? If yes, then check whether second and third number are the same, and then we output 3, considering if all are the same. If the last condition is not satisfied, we place 2 of them the same, because we are already satisfied the first condition, A equals B. Second part, I'm just exchanged the second if to or. Split. Don't forget splitting. All right. Two. Zero. Yeah, okay, works fine. The second one using cascading operator, we just exchange if A equals B and B equals C. Else A equals B or B equals C or A equals C. Here's 2. Other case, 0. So cascading operator works like that. And another approach, the final one, where you use the set data structure. Unique numbers, they are like that. We place them in the set data structure. Set data structure allows all the values to be unique. Inside the set data structure is the list, ABC, for example. Array is this one. And we check the length. We check the length. So if there is only one unique number, that means we entered 3 same numbers, it will be 3. If 2, then 2, and 0, that means not 0. In all other things, that means they are all unique. Different numbers, then we place 0. Again, if you need to check how the code works, place ABC in front of each chunk of code. And over here. Just like that. Alright, so sometimes data structures allow you to check everything much easier. So let's pretend that we are constantly reading that array of numbers with millions of them. We might read it from the text, from the internet, or may read them online, and so on and so forth. Just separate those chunks of numbers, calculate the length of the set, calculate the length of unique numbers, and just output like that. What I suggest you is to use approach number 2, using cascading conditional operator. Much easier to understand actually. Again, if you're thinking that something here is wrong, please brackets around. It won't be a mistake. It just make sure that we check this condition, we check this condition, we check that both they are true. The same kind of thing happens over here. A equals B, or B equals C, or A equals C. Again, check those conditions. If any of them is true, then we will print 2. Right? So that's it for the theory. You'll still have like 50 or 60 minutes. Try tasks. Altogether you have 9 tasks for today. And raise hands, I'll help you if you need. Stop the recording.